What do you think would be most useful?
We definitely want to put bounds on them in terms of the pressure, so they know if the system is operating in the range it should be.
Okay, so you wanted to put some boundaries on where they can do the compressed air? Okay.
And we want to understand the application.
Understand the application, that's always a good place. It may need to be different in different areas. Different
Yeah.
areas may have
Yep.
different needs. Good observation. Anything else? One of the biggest things for compressed air is leaks. So in terms of maintenance, connecting that to leaks would be a really good opportunity. Compressed air is one of the most expensive forms of energy for the organization. So minimizing it, finding other uses is sometimes a better solution.
Okay.
So, you know,
Don't blow it on the boilers.
yeah, don't blow it on the boilers. You know, is there another way to do this? I mean, there are some things that have to be done with compressed air, but not a lot of things. And so if it can be done another way, you know, what do those options look like? So compressed air kind of reviews are really helpful. And that may be something you have to do more than once. You're not going to catch everything the first go around, but maybe maybe you start with where they are. And improvement one is you kind of take a look at the pressures. I know I would accidentally kind of turn it down by 5 pounds per square inch when I left on Friday and see if anybody noticed between then and the next Friday. If they didn't, I might do it again. I found not telling them in advance was very useful because they didn't notice. And you know, after about 20 psi, I'd say, "Hey, how's the compressed air thing going?" And they would say, "Oh, it's going fine. Good, good. I like the new pressure then." And then all of a sudden they had problems. So sometimes the pressure is up here. You know, you might see how you can adjust or cut things down. That's definitely an option. Where the drops are, they may not be located where they need them. Those are some of them could be discontinued. They may not be using those anymore. Remember those Kaizen people who move things around? They just turn the air off. They don't, or as off as they get a chance to, they don't actually move the drops. So there may be drops that are partially closed but not fully closed. It's a good example of a leak. Lines, of course, hosing leaks all the time, so that's a good one. So, you know, taking a look at those kind of things. Let's see where they are now. Let's see if we can reduce pressures. Let's see if we can put in a leak program. Let's see if we can change it out to a different use. So it's kind of a progressive improvement, starting from where they are, taking them to best practices. So that gave you an idea for operational controls. This could be something that takes a little bit of time. This could be something that you have to do a little bit of research on or reach out to some colleagues on, and that's okay. You don't have to have all the right answers instantly. You can get back to them. So just kind of keep that in mind. Anything you thought was interesting or really easy or really hard in looking at operational controls?
I mean, I have some familiarity with air compressors and the systems, and it actually was something we spent a lot of time on in one IEC visit I was on recently. But a boiler or anything, I really don't know much about it at all.
Okay. So it may be something where you need to partner with some other experts. Everybody has their strengths and weaknesses. It's kind of like an environmental. Not everybody doesn't know the details of every rag. They have areas where they specialize and where they do certain things better. Doesn't mean they don't know about it, but they know enough to be dangerous, not the gory details. Same thing happens here. You know the details of a system. You may not know all the systems, and that's okay. So it's okay to work with as a team. And this may be an area where you decide that you need a team approach, and there's nothing wrong with that. There's nothing wrong with having somebody else go out and look at a particular system.
Is it city's responsibility rather than the firms, or we just check that?
It kind of depends on the level of the organization and what they need. You definitely need to make sure it's happening. But you may have somebody else who knows the system better help you with the detail of it. And it may be that they look at the detail and say, well, this is where they are today, and that may be with what you start. And then you might build a plan over time to make some changes to where they are. It may be that you look at where they are and they need some changes right now. So it just kind of depends on where the organization is. And remember, these are focused on SEU, so this is something that typically they know needs to be managed. So they may be aware that there is an issue in the system, and they may be looking for you to provide some options within operational controls to get those performance improvements. So a part of the answer depends on what they want to gain out of it, what's in it for the company. Part of it depends on where the company's starting from. But as a CP, you'll have to kind of, figure out the best mechanism for you. But in the end, yeah, they're looking to you to help them make sure this is implemented and effective, and they're going to get that
Probably
certificate.
need a lot of help from the guys who actually operating the system or
Yeah,
know
you do.
more about
Yeah,
the
you
system.
do.
Yeah.
But that means you're going to have to go to them, and you're going to have to talk to them, and that's going to take time. That's going to take time.
Another question is for the auditor.
Mhm.
How the auditor is going to check this sheet? So are they going to make sure the sheet cover all the important stuff, or they just say, okay, there's a sheet, that's fine?
They're going to look at the sheet and then go look at the equipment, see if the sheet and the equipment match, ask them what happens if something is out of whack, ask them what they do and how they learned how to do this. So they're going to check competency. They're going to check, do you keep records of this? They're going to check, do you have any documents that tell you how to do this? Okay, you have these ranges, what happens when you're outside of them? They're going to do that's kind of the basic pieces of that audit. What do you do when you're outside? When do you investigate? When does your investigation turn into a corrective action? So those kind of trails. Well, in that case, you're probably ready for a new topic. Maybe. Maybe not. There we go. Your happiness here. So, just so you have an example, that's one of these filled out, and this is the criteria worksheet filled
So
out.
did we have the information in the case study to actually fill it out to get these answers? Because that's what I was doing. I was trying to find temperature. I was trying to find anything I could to fill this in with actual real data. I wasn't going to sit here and make stuff up because I don't know how to operate an air compressor. And I couldn't find anything. So was I looking in the wrong spot?
I don't think this
No, we
data's
don't
in
need
there.
any of that.
I don't think it's in there.
Okay.
Yeah.
So the number, just we just build
Part of the exercise is,
Make me crazy? It worked.
well,
It's perfect.
that's energy management. The concept is, that what does an air compressor do? Tell me what it does,
Compresses air.
which implies what kind of reading might be important.
Pressure.
pressure.
So I'm not, if you have any chemistry or physics at all, you can appreciate there may also be some temperature relationship
Right.
associated with that. So
Right.
the fact that it's rotating equipment means that there are probably some other lubrication things that you're worried about,
Sure.
filters, to clean the air up, that kind of stuff. So it's just having an appreciation, because you very likely could be, and I can remember in a couple of Chrysler plants, they had die casting operations. And I don't have any expertise with that. I can appreciate that they melt aluminum and they have injected into these things. But all the nuances that go with that, how critical is moisture, or, I guess the point is that you can rely on a certain amount of intuition to help you, but you're going to be working with, a client who knows their own equipment. You don't
Yeah.
have to.
Well, no, that's good. I mean, because unfortunately that was like right away, I was like, well,
Well, turn it around, imagine that it's an ethanol plant.
well, right, but that's, immediately I would be like, I'm not gonna sit here and waste my time making up numbers
Right.
when
Right.
I'm gonna go to the expert.
Yep.
Yeah.
Right.
Yeah, and so I right away just shut down on this whole thing, because
Yeah.
I'm like,
Well,
I
I'm
don't
sorry
know.
about that, right?
No, but that's not your fault, because then I'm like, okay, I gotta. like,
Well, we
start
should
thinking outside the
probably
box.
restructure the exercise so that maybe what would be more important would be for you to think about the roles or positions that you would go to
Sure.
to try and develop this or help the organization develop this.
But I think
That
it
may be better.
depends on, people in the room. I suspect there's mechanical engineers in the room that were up for the challenge, where I was like, oh, I'm gonna go talk to the right person.
Yeah.
Because that's where, that's what I do.
Right.
That's where my strongest tool set is. I don't,
So maybe the worksheet
You
for the
know.
exercise should be, you know these parameters and put them in, but if you don't, then over here is this
sure.
follow-up box to say,
It would
Joe
be a
Schmo
task.
knows all that, and that's
Yeah.
who I need to talk to.
No, there's nothing wrong with the exercise. I just,
But that's a very important point for a CP. There are gonna be parts of being a CP that are very much in your wheelhouse.
Yeah.
And there are gonna be parts that are very much outside of your wheelhouse. Because the roles of the CP are very broad. It's everything from understanding document control and awareness and training,
Sure.
and the people side of it, to understanding the technical energy pieces. And that's a very,
right.
broad thing. So it's
Sure.
not typically a single person who can do that whole range
Right.
of
Yeah.
things. It is usually a team, or it is usually identifying who within the organization can help you make them successful. So don't necessarily feel like any one exercise is something you have to be expert in.
Yeah.
So that's, that's an important thing to keep in your head. It's not, there is a very large range of skills here, so it's not typically a single person who does. Sure.
Well, the other thing we could do is pick something generic that everybody has experience with. This might be their own automobile, what operational controls you put in place to manage the energy performance or maintain, proper operation of your automobile. And you have some idea what that is.
Sure.
Or some documentation, for example, the compressor, there is a piece of documentation about how they actually works or how they actually using that. And we can read that documentation and then do this exercise.
Helpful discussion for me, particularly. I don't know if you heard any of that, Jennifer. Okay. Very good conversation for an instructional design. In the end, I ran off and left my copy of 50,001 laying on Holly's desk. Standard out. So we're going to turn the page, actually, in more ways than one. So I might point out, it might be obvious to you, but bear with me on exploring the obvious for those who hadn't noticed. We've been looking at today everything in 455, which is the do part, or the standard refers to 4.5 as implementation and operation. So if you turn the page from 4.5, we start 4.6 with the checking. Remember, plan, do, check, act. That's what a management system is built on. So the checking function is getting feedback about how we had planning. We talked about that in the first day in a few hours. And then we've been talking about the do, or the implementation of this. So now we want to talk about, shift gears and look at what is involved in getting the feedback about what we've implemented. We planned, we put into action some things to help us achieve those objectives and targets that we set in planning. We're managing and controlling our significant energy uses. We're operating and maintaining our systems the way they should be. Now it's time to ask, how well are we doing? So think about that. So our objectives for this section, and this is 4.61 in the standard, which is monitoring, measurement, and analysis. We're going to talk about what the standard refers to as key characteristics. We'll look at what that means, how to interpret that. Key element for the CP is to have a pretty good understanding of how to direct the organization to develop and implement a measurement plan. We'll talk about what that means. To understand what we have to do to keep our measurement, keep a proper assessment of our measurement needs and keep the right measurement plan in place for the organization. And then, of course, the requirements to ensure that the measurements that we take are accurate, appropriate, reliable, repeatable, and so forth. Have you figured out how to get this remote to actually change?
Oh, no, right now.
So monitoring, measurement, and analysis. Monitoring is kind of the passive or periodic checking that we do. If you think about taking an exam, like the exam you take for this course, somebody's going to proctor will monitor your attendance at the exam. The exam itself is going to be a measurement of what you know relative to the questions that were asked, right? So measurement is an active, dynamic, often reading that you're taking with some value or engagement. Analysis is then what we do with the collection of those sets of information. So monitoring, measurement, and analysis is the section. Look at your standard for a minute. There's probably half of the fiber that it requires for this section is related to this term, the key characteristic. Read, follow along with me. The organization shall ensure that the key characteristics of its operations that determine energy performance are monitored, measured, and analyzed at planned intervals. Stop right there. So you probably read this before. If you're familiar with 50,001, you took the pre-course and it was maybe somewhere in there. What does that mean to you? What is a key characteristic?
The parameter that can tell you the story or help you to understand the performance.
So
What-
it's actually going to affect your energy performance.
Something that we would rely on to help us know how things are going and how we're doing. They go on after that sentence to say key characteristics shall include, and Leanne can probably tell us why this phrase is here, at a minimum, which has a certain qualifier to that statement, right? In other words, you might have more, but at least you're going to have these items. Significant energy uses and other outputs of the energy review. We're going to come back to that statement. The relevant variables, I'm probably going to get ahead by going through this, but relevant variables related to significant energy uses, ENPIs, the effectiveness of the action plans in achieving objectives and targets, and the evaluation of actual versus expected energy consumption. Before I press forward, I will confess as an engineer, when I read monitoring, measurement, and analysis, and I know this is where calibration has its teeth in 50,001, I'm expecting to see a list of things I can actually measure, right? It's the energy consumption, it's the SEU performance, but it gives me this kind of vague list of these general terms of things that we talked about around about. How do we apply that? How do we interpret that? How do we come up with a monitoring, measurement, and analysis program that actually helps us? It's not a bunch of busy work. So you talked about, when I asked what your definition of key characteristics, this is what you described. These are the things that help us know how well we're doing, and tell us that we're, moving in the right direction. So I think about it, as in the medical field, we might call these the vital signs, right? We're going to take your temperature and your pulse and your blood pressure, maybe do a little blood work and really understand your current state, and also be able to talk about, if we have some analysis of that, we can say, here's how much you've improved, or here's how much you've declined. We have to identify what those appropriate intervals are, because both monitoring and measurement imply some type of, even analysis, right? You don't do continuous analysis for most things. You do some kind of periodic analysis. We look at every month, we look at every week. If you're running a paper machine, you do watch it every minute, certain variables and certain things. So, and the important thing for you to remember as the CP is a big part of our time in the energy planning process was building this data set that's going to drive our identification of uses and our selection of SEUs and our evaluation of performance, the development of our energy performance indicators. All of those are things that imply or that are going to be implicated here. So the good place to start is what were the sources of the data that we needed for the energy review? And that's kind of the short list to start with when you think about monitoring, measurement, and analysis. So here's the minimum list of key characteristics that we talked about. In that definition from the standard, there's 6 items listed. Some of those are fairly easy to see how there might be a measurement related to that. ENPIs, of course. In KRM, we were working on their measurement plan. We know they measure consumption of electricity and gas. We know they measure production in tons. Those are all inputs to the ENPIs that they have. But what about that? How does that impact the measurement plan in our monitoring and measurement analysis? So our significant energy uses are a key characteristic. You remember what the energy review required of us to do? There were 3 little bullets underneath 443B. Anybody remember that? Yes, I have to know the current performance of my SEU. We talked about there's no specific requirement that you have an ENPI for your SEU. But you get over here to the monitoring and measurement plan, it says one of the key characteristics that I have to monitor, measure, and analyze is my significant energy use. What about my significant energy use? Do I want to monitor, measure, and analyze? Well, the end talked about the operational maintenance controls. That's part of the inputs. How do I know the pressure gauge is right? Maybe the air compressor is running over pressure, but the gauge is stuck. I'm wasting electricity making a pressure that I can't use. You have that component of it, but also we have to know, or we have to evaluate the current performance. Well, how do I do that without having, measurements? The relevant variables that might impact the performance of our significant energy use, we have For the steam system, we talked a lot about boilers, maybe temperature. I'll tell you a little trick, Angie, for air compressors. There are two basic types in industry. There are positive displacement and they're dynamic. So, are y'all familiar with like a turbocharger on a car? Have you heard that phrase before?
I've heard it, yes.
Have you ever been beside a big diesel truck and he steps on the gas and you hear this whistling noise? That's his turbocharger cranking up because he's pouring the exhaust through the turbine. Well, a turbine, they use turbines to compress air in industry. They're big air compressors, hundreds of horsepower. And they make lots of air, and they're very efficient thermodynamically, but they're called dynamic devices because it's a spinning wheel that boosts the pressure between, the atmosphere and some higher pressure. Whereas most of the compressors we're familiar with are at the service station or, the repair shop where there's a piston going back and forth and it just pumps up, squeezes air into a tank. That's positive displacement. This is more than you want to know about it, but positive displacement is not that sensitive to the temperature. So they're usually sitting in a not very comfortable spot of the plant. And it affects them a little bit to say that they're totally independent, but on a hot day, it's a little less efficient than on a cold day when the air is denser. Moisture content probably has more to do with efficiency in that realm than anything else. But a dynamic air compressor, like a centrifugal, if the intake air is 100 degrees, it's probably 15 to 20% less efficient than one that had an intake at 50 or 60 degrees. You always see centrifugal intakes piped to the coolest air they can find, usually outside the plant, for that reason. Just starting with denser molecules, so it's easier for the impeller to pack them closer together. It takes less work to get over that hump and get it out.
Do we have to stay in a conditioned area space or just outside?
Well, if you can put the intake in conditioned air, it's going to be even better. The problem is you're also paying to condition that air that it's intaking. So you'd have to evaluate the effectiveness of that, whether it's really worthwhile. I say all that to say that if I had an air compressor, we talked about temperature and boilers and steam systems, but certain air compressor systems may be sensitive to the ambient temperature as well and their performance. Our ENPIs and the SENPI, think about the data. We gave you a very simple example in what we walked through in the class. When you went home work on KRM's data, we had, 4 weather variables? Is that right?
Yes.
And 3 production variables. We ended up with 127 possible combinations of models. But just that one term alone may create a whole list of things now that we have to worry about monitoring and measuring. I dare say most industrial accounts that I've worked with have never been too concerned about having accurate weather readings. They watch the weather report like everybody else, and they kind of keep up with it, but they weren't trying to log NOAA data to keep up with heating degree days and cooling degree days. Now all of a sudden you have to, if you're using it in the model. But the other ENPIs in the organization as well. So how would action plans be implicated by our need to monitor, measure, and analyze information? Yeah, how am I going to track my progress, right? How much did this action plan contribute? How much did that one improve? What can I expect my future energy consumption to be now that I've implemented project 4, 5, and 6? How much progress have I made towards that 5% reduction objective that we have? And how do I know that I'm at 3%? I had some expectation that I built these objectives and targets around. How am I doing? Well, what are the other outputs of the energy review? That's kind of an odd phrase. Ian might can give us the history on that one too. But if you think about what we did in 443A and C, in A, we identified energy sources, we identified our use and consumption. We estimated future use and consumption for our SEUs, and we prioritized our improvement opportunities. So it's not just a calibration sheet of leaders that we have to calibrate, that we keep up with in this part. The real focus here is that all of these are inputs to our checking function. I'm going to evaluate how well I'm doing based on the collection of these objects. Am I maintaining control of my significant energy uses? What is their performance and how well is it doing? Do I understand the impact that the relevant variables are having because I'm actually tracking these temperatures or these pressures or whatever else is going on? Are the things that we're working on, are they getting us where we want to go? And are we keeping an eye on our current state? So how do I make sure that another energy source doesn't get introduced to the facility and I don't have sight of it within my energy management system? Because the goal of the energy management system is to manage energy within the organization. All of those are considerations we have to think about as we work through this process of monitoring, measuring, and analyzing. So how can you measure the performance of a significant energy use? Certainly meter data. If it's a chiller, you can probably get the meter built right into the control panel. Same with an air compressor or other equipment. There's a lot of automated stuff. But I have seen people, organizations that don't have the means or didn't have the means, and it's certainly not intended that you have to have meters to be, there's nothing in here that says performance, the determination of performance for the SEU has to be done with the meter evaluation. I told you the example about the air compressor companies where they just looked at the number of hours they had to run the second air compressor. In a sense, that was metered because they had an hour meter. But literally, they could have just said, we operated 3 days this week on one air compressor. So sometimes in some very early implementations, all they have for energy is their primary utility meters. Sometimes the SEU is large enough that they can actually just monitor its impact, how well they're controlling it at the primary meter. Now, in a very large facility, that's going to be quite difficult because there's too many other things in there. But if you think about a 200 or 300 or 400 person organization and they have a 2 or 3 200 horsepower compressors and then a lot of other ancillary equipment in their shop, their managing of those air compressors is probably going to show up in that primary meter. So you can do it that way as well. But you can also take spot measurements. So 3 times a shift, we're going to take the readings, or when we're running certain parts of the process that we know that are certainly intense to the need for that SEU, we're going to take measurements and understand how we do it. Why is it important, do you think, that the standard talks about the relevant variables for our SEUs, and why do we have to worry about our ability to measure and analyze those relevant variables?
The drivers for usage, because they drive the energy usage for the.
Yeah, part of, our developing expectations about performance are really key drivers. I would say maybe it's one of the culture change things that happens with 50,001, because before they just went along and, unless the bottom line got affected, nobody really even noticed how many BTUs were involved. So now you're saying I have some expectation I can get to next week, next month, or next year, and this will be the impact of this SEU on my energy performance. Well, now that I have an expectation, what do I have? I have some basis for determining how well I've done when I get there, because I'm either better than my expectation, or I've arrived at my expectation, or I'm worse than my expectation. And it's really, if you think about, you ever had a class in automatic controls, it's that feedback loop that really gives precision to your efforts in this regard. All that around relevant variables is, let's say that I determined that the ambient temperature, the heating degree days had a very significant impact on my steam system. And that's my SEU. And I rock along, do all these improvements, and have a really mild winter, and my gas bills are really small, and it looks like we've done a really good job. So my expectation is that we got this thing under control until the following winter comes along. So it doesn't tell you how to do it, but you should always have that in the evaluation. How does these other things affect my expectation, my determination, my understanding of how well it's operating? And significant relevant variables here, also include the things we're doing in the plant as well, not just those things we don't control. So if they walk in and tell you that next year we expect production to be twice of what it is this year, you can appreciate, hopefully as this develops, you will have an appreciation for the impact that has on your compressed air system or your steam system or whatever, however you define your SEU. So our energy performance indicators, to me, this is probably the most straightforward piece. If you remember, the definition of energy performance starts by saying it's measurable results. Well, there's that word, measurable. Measurable implies measurement, right? So what meters drive the data that I need to develop my SEUs? And then what other data do I need to complete those performance indicators? Things like production or hours, or it could be a lot of things. Energy use and consumption, that's pretty straightforward too. By definition, just to make SEP keep it from being totally insane to implement, by definition, utility meters are calibrated. So we can rely on them if they're coming, those readings, if they're coming through a revenue transfer meter. So future energy use and consumption. Some of this we might actually measure, not just monitor, but those could all be inputs. There are other things as well. Why would we list economic forecast? We didn't list weather forecast. You know, to me, production forecast and economic forecast are really the same.
Yeah.
I'm using this to understand where my, you know, my product or my markets are going, which is gonna drive my production forecast. Though economic forecast might also affect my energy profile, right? If gas got tight, I might expect more interruptions and I have to burn more propane or fuel oil in the winter because my service has been interrupted, so there are other things we might consider there that feeds our future expectations of use and consumption. As we saw at KRM, you know, they can run 2 of those spray dryers off of fuel oil, get cheaper natural gas, but it hurts their burner efficiency to do that. How do we know that we're meeting our objectives and targets? We're going to look at, you know, consumption data. We're also going to evaluate action items. And we really talked about that already. So what meters do you have in place? Typically, when I do this, when we get to this part of the implementation with the company, what I'll do is pull a spreadsheet out and just go back through the energy review and list all the things that we had data that come where the data comes from. So we start with energy sources. Where do you get your electricity consumption? Well, it comes from these meters. Where do you get your gas consumption? It comes from this meter, that. As I told you, the Marine Air Station in Beaufort had 43 natural gas meters. Like 12 or 14 were unknown to them when we sat down to do this. And lo and behold, we started digging around and we found all these other bills and meters that we didn't know existed. And but then you move to the other parts of the key characteristics that we just went through. How are we going to know that our action plans are being completed? Is there some status report or some tracker? And we just really list all the things that we need to, that are monitored or measured as part of our energy management system. And that becomes kind of the first draft of the measurement plan, which we'll talk about. But the other things that we ask are, you know, if it's a meter, if I have a steam system and a steam meter and I need that steam meter to give me the pounds of steam we produce so I can evaluate the efficiency of my SEU, does the meter require any calibration? Is there somebody responsible for taking a reading twice a shift? Who that is? Is there somebody responsible for keeping things updated or collecting or storing the data? Another good example of this we went through at the Marine base, they included their motor vehicles, not the jets, but all the base trucks, and they had a couple of hundred, you know, things that just ran all over the base doing different maintenance and other activities. The motor pool, I guess, for lack of a better word. And that was managed by a whole nother group. So how much fuel, that fleet of vehicles consumed was tracked by that group. All the records were located in the motor pool office and so forth. So it became a key thing for the utility manager in this process. He got a clear view really of where all the energy data was at the base and who had it and how it got organized. And this proved to be very helpful to them in just some practical ways as well. You know, but who owns the data or the information? How is it stored? And how is it reported and so forth? So it says we have to analyze our key characteristics. That's totally open to interpretation. What the organization does for analysis needs to meet the organization's needs. It doesn't need to be, you know, sometimes if you've done this a lot, you may see something that one company does or one organization does, And it might cause you to ask some questions that help them develop this, but for the most part, they already have some way of analyzing or thinking about it. You know, Chrysler monthly looked at their energy intensity per vehicle. Marine Air Station had to report monthly up the chain. And they charted their MMBTUs per KSF, 1,000 square feet of facility. The interesting thing, or I think the best way for you as a CP to add value in this process is to help them think about this question. Are the traditional ways of analyzing your energy performance and data, and this happens also when you're looking at the ENPIs as well, but does that really help you know how to improve energy performance and impact the bottom line? Because a lot of times it does. It's just a number that gets reported or it's a measurement. And so there may be more meaningful ways. That's the SENPI, the modeling tool that you saw yesterday. That really impacted a lot of people when they saw how they could actually see what the impact of weather was, and just not using the simple intensity. But where's the analysis? How is it reported? Where's it reported? You have to think about this in this process. Again, I try to plug in as a CP where the organization currently is. What reporting do you currently do on energy performance? Who does that go to? How's it done? Where's it analyzed? Where's the data come from? And then we try to build onto that anything that we need to complete this picture. We don't usually have to start from scratch here, and we should in most cases. Sometimes analysis, this is just an example, the analysis may be fairly automated. For the types of things Deanne was talking about under operational controls, or it could even be for overall energy consumption, right? We might have these control bands, these upper and lower control limits. And as long as we're rocking along in here, we think we're doing good. And so this data point right here automatically lets us know that we have something that we need to investigate, report. It just depends, This is a common statistical process control technique. Figure out what these limits are, how tight you need to control this to maintain control, and your analysis is done. We have one period here that we need to really track down and run into. Another analysis that I don't know if we mentioned it in the slides, I'll mention it here, is the QSUM. I talked about it earlier. If you look at the Georgia Tech tool, if we have some time today or tomorrow, I'll show you that ENPI tool. At the back of it is a QSUM graph, which is the trend of that is a really good indicator of whether how your overall energy consumption is trending. But that kind of analysis can be helpful as well. It's almost like an automatic visual to see where you're headed.
So let's say like the analysis of relevant variables. So it could just be going through the logbook and seeing notice, just seeing everything is within control.
Right.
So it need not be a graph or anything like that.
Right. And it's totally, we'll see this in the definition of the measurement plan, but it's totally up to the organization to make the monitoring measurement fit for its culture, and you as the CP really need to see that it's complete and that they've thought through everything that needs to be included. I should read you this note. If you look at the standard, and then we'll jump down to the next part after this. So it says measurement the note, measurement can range from only utility meters for small organizations up to complete monitoring and measurement systems connected to a software application capable of consolidating data and delivering automatic analysis. It is up to the organization to determine the means and methods of measurement. So it's really not intended that you have to have this high-end fancy-dancy, integrated control system to get 50,001. You could just have utility bills, and that may be all the monitoring measurement that you've got for the moment.
And that will kind of like expands to monitoring and analysis.
Right. So if you look at, I'm going to skip the next paragraph, go down to the next to the last paragraph or sentence. It says, the organization shall investigate and respond to significant deviations in energy performance. So when do we have a significant deviation in energy performance? When do you think?
That's what we talked about before.
What's
Over those
significant?
limits that we say, yeah, exactly, it's judgment.
Yeah.
Depending on the good condition.
The important thing for you as the CP in implementing this is to help them figure out how to define what's significant. So if they implement the management system and have left the definition of significance undefined, that will probably be a finding. Fairly easy to fix, but then once they define it, if they had several instances where they had a significant deviation, then they'd have other findings, because the standard requires that we at least investigate what happened. So my experience with industry has been, they will take kind of a high-level view of this and say, any change in our overall consumption by plus or minus 10% in 1 month is a significant deviation in our energy performance that we will investigate. Or it might be, it could be related to an ENPI, right? It could be our intensity changes by this or that amount. A lot of times it'll be this same month last year, the comparison of that over, plus or minus a certain thing. But it could be in any way that makes sense to the organization. Don't let my suggestions limit your thinking on how you define what these significant deviations in energy performance are. How do we demonstrate to the auditor that we did an investigation and that we understand what happened? How do you suggest we do that?
Some sort of recommendation.
Such as,
I mean, at the simplest level, an email explaining to whomever's responsible for that. Maybe even a more thorough logbook.
so there's actually we're going to look tomorrow at section 464 called nonconformities, correction, corrective action, and preventive action. So you are required by the standard to have a corrective action system, which is a log of things that we have to investigate, do root cause, put in a correction, and there's a whole process associated with that. That's part of the continuous improvement model, having a corrective action system. A lot of people who are familiar with management systems, and they get to this part of the course and they go, well, you just log it in the corrective action system. And what I want to point out is it doesn't require you to do that for this investigation. It could be a chain of email threads. That's pretty common, actually. The energy manager will investigate, and he keeps this file folder of emails where he's investigated and responded to significant deviations. And that's what they show the auditor. Why do you think that we have this in the standards? Why would this be important for energy management?
If you're not dealing with things when they get out of whack, you're not continuously improving.
Right? Think about it like this. If you're gonna drive from here home or from your home to some favorite destination that you have, you will get a ticket if you continually drive above the speed limit. It's just a matter of time, right? You make the trip often enough, your path will cross somebody in law enforcement who has the authority and the means with which to remind you of your legal commitments in that regard. So occasionally, and you might set the cruise control, but that can't stay on all the time because you have to hit the brakes and that kind of stuff. But occasionally, you look down at the speedometer, you know, or you see when you see a speed limit sign, do you look at the speedometer? Yeah, probably. Most of us do. Oh, yeah, okay, I'm good. You know, because what happens if you look down and your speedometer says 80 and the sign says 55, you're going to make a correction. You're going to do something to change what you see. You know, you're going to respond to that, and that's what we want to happen. If you deviate from what you said is good operation or good control, you may not be able to do anything about it in the case of the car example, but you at least understand what happened and why it happened and how it happened, so in your planning cycles in the future, you can consider that also as part of the inputs. Because all of this is a learning process. It's continual improvement. And the more of these that happen, you might say in one sense, well, you're out of control, but you're also learning. So over time, you should see a degradation in the number of significant deviations that you have if your system is really helping you improve. You get to determine what's significant. When will we cross that line? If I was an auditor and I did your initial certification, you may not have any significant deviations because you only have a few months of history, right? When you rock along for 3 years, you get recertified, you still hadn't had one. Now I'm doing your second recertification. It's been 6 years, you've never had a significant deviation. Now, you know, you've got these control bands on, it's so wide that basically, you know, the minimum. Your intent is, I want to define this so wide that I never have any and I don't have to deal with this, and that's not our goal. Our intent is to get it better. And so at some point I would say, in an audit, I would say I'd provide an opportunity for improvement or concern that you hadn't had any. Maybe you should consider the limits that you placed on significance. So the goal is not to not have significant deviations. The goal is to define it in a way that they really do mean something to you when they happen and you can respond and correct. These are just some methodologies coming mostly from the statistical process control world and how, in the lean world, and how to do investigations. Your management system should clearly point out how they'll be handled, you know, where the record is of the investigation. A lot of times the investigation is, you know, we had a water pipe freeze and break, and this is what happened, and there's not much we can do about it. But you at least know the investigation is not here's how we fixed it. We at least understand what's caused it, and you have to keep a record of that. So that last big paragraph, the organization shall define and periodically review its measurement needs. Organization shall ensure that the equipment used in monitoring and measurement of key characteristics provides data which are accurate and repeatable. Does it say calibrated? Records of calibration, there it is, and other means of establishing accuracy and repeatability shall be maintained. So if the only way to maintain accuracy and repeatability is calibration, then that's what you'll need. But that's not necessarily always what you do. Well, that's probably not the right way to say it. You have to ensure that what you're reading in your key characteristics you can rely on. If you have another way of relying on that reading without calibration, then you can do it. I mean, a lot of meters today, most electric meters, you can't calibrate. They don't need calibration. Typically, flow meters need calibration. Things handling compressible substances like gases, mechanical meters, those have to be calibrated. How much accuracy is required, and what is the frequency of that, and that goes in when you're creating that list. Well, here are the 4 or 5 items on it that have to be calibrated. The Marine Air Station, which is the most extreme example in terms of this topic that I keep referring to, they had 40-something gas meters. They had they only had a handful of electric meters that were utility meters, but then they had all of their SEUs had their own electric meters on those buildings. So all their SEU performance was really driven by their own internal meters. They didn't use utility meters for that. Well, those had to be calibrated, except that the meters they had didn't require calibration. And my point was they had hundreds. Literally, by the time we got through with the fuel and electric and gas and all the other things in those key characteristics we talked about, they had hundreds of things on their measurement plan, and they might have had the fuel pumps that dispensed fuel to the vehicles were the only things that had calibration records. Because those were mechanical meters, they had wear and slip, and so the state had to come by every so often and validate that they were, meeting their delivery. That little sticker you see on the gas pump when you buy gas, somebody in your state goes by and make sure when you pay per gallon, you get a gallon. And that's just the calibration. So it's been my experience, this is not a really big, it's not a big calibration thing for energy. But we want to make sure we can rely on this data and that it's done effectively. The measurement plan we put together for Beaufort ended up being a multi-tab spreadsheet. They had a tab for utility meters, a tab for their own internal meters, a tab for the fleet fuel meters, and they attacked it that way, and they had columns for all the things that they needed to keep up with relative to that measurement. What data it supplied and all that. I've asked the guys over there about it. It's actually probably public property anyway, since that's U.S. government. And I'll be glad to show that to you if you're interested in seeing it. That was their measurement plan. The measurement plan does not have to be the document. It's the place, the measurement plan is usually where the auditor weighs into this topic. So they'll sit down with the management rep and say, can you show me your measurement plan? Or what is your measurement plan? That second paragraph under the list of bullet items, it says an energy measurement plan appropriate to the size and complexity of the organization and its monitoring and measurement equipment shall be defined and implemented. So I've seen the measurement plan done in pieces in the sense that they had all of this process control equipment over here, and that part of the measurement plan was encapsulated within procedures and process that they had for that. In other places, the energy manager might collect the miscellaneous stuff related to action plans and the utility bills in a spreadsheet, his folder or something like that. But you have to develop a plan, implement it, and use it to manage the monitoring and measurement of your key characteristics. So software is a good way to do that. It's not uncommon. So think about it this way. All the things that we've done in the implementation, all the things that we've gathered data for in the planning stage, where does that come from? How can we know we can rely on it? And how do we know that we will be able to continue to rely on it? And answering those questions, that's what goes on the measurement plan. And that's really all we're trying to get you to consider here. Sometimes, especially if you have an air permit, there may be certain meters. A lot of times, the natural gas meter on a boiler will be tied to the air permit. You know, they have to take those readings and that kind of stuff. It's not, I haven't seen it that common that there's much on our measurement plan that's impacted from a legal perspective. There's a little bit here, there is some on the exam about understanding what is accuracy, what is calibration really all about. We want to just talk about that real briefly. As I said, it's not as big a deal, but it is something that CP needs to be aware of. As I said, have an appreciation for the fact that a flow meter probably needs calibration when some temperature probes or thermometers and electric meters typically don't. Some thermometers can, depending on the type and style. I can assure you, in the process world, if their quality depends on a gauge or meter being accurate and calibrated, they do it. So a lot of organizations already have this well established and in place. Frequency really is a function of the type of device. As I said, some electric meters never need it. Some meters need it every so many hours, some need it every annually, but the manufacturer really is the one. There'll be some recommendation from the manufacturer on what's required. And I said this already, for our utility or transfer meters, those are defined as accurate within the standard. Electric meters typically lose about 1% in 10 years. That's the meter on the house. They're probably a little better than that now because they're not electromechanical. Most of them are electronic. Flow meters, plus or minus 1%. Most of the time, the scale of our energy measurements, we're not worried too much about the detail of this. But just having an appreciation for the types of ranges can be helpful to the CP. An ultrasonic flow meter has a less frequency maybe than a mechanical flow meter, like a gear type or a turbine type. Thermocouples have to be tested pretty frequently, whereas a resistance temperature device sometimes doesn't need it. In this case, we say typically annually. This is an actual graph on the electromechanical meter like they use on your house. You can see it's still above 1% after 10 years. And typically they're replaced, those are replaced. They came through my neighborhood and replaced ours about 5 years ago, but it was so they could get rid of the meter reader. Because now the meters just send they talk to each other and send your reading back to the power company without anybody having to come out and read the meter.
So the meter type is still the same?
Do what?
The meter type, like you said that it's still meters at your neighborhood, that's the same meter type as the previous meter?
No, it's not electromechanical. Electromechanical had that little disc in there that turned around.
I mean, mine still does.
Yeah. You might still have that. So the current that you draw in the house controls the speed of that rotation, and they count the rotations, and that becomes the amount of power. So they count those rotations. The new ones are electronic. It's all, like a current transformer, solid state, and they're logged with that.
And they can help
Right.
you, like
But the important thing for us, even if I was doing SCP over the 10-year period, and I'm using this reading, you know, if it was a brand new meter back here, and I got all the way out here, you know, it could affect my performance maybe by a fraction of 1%. The way everything else is built into the MMV protocol, we don't really worry about it. It's not gonna make much difference in the time frames that we're normally talking about. In the 3 to 5 year time frame, it's almost immeasurable. I'm trying to get to the end, see if we can take a break. Might need to just go ahead and give me one. If y'all wanna do that, let's take a 2-minute break. This can get pretty dry, I understand that too. I'm trying to make it exciting and interesting for you.
There's always so much you can